Hi guys, how you doing?
Hi guys.
We've got solubility curves today.
Solubility curves.
Get ready to read some graphs is basically what this is. What you see here is we've got a graph of solubility versus temperature. Not all solubility curves look the same.
Now these are salts, so these are all solids, correct? In water, right? Because if you look at the y-axis, it says grams per 100 grams of water. So these are all solutions of salts in water.
Right, so what it's telling me is that I have, I can dissolve a certain amount of grams, and that's that first grams of the salt per 100 grams of water.
Okay, so the 100 grams of water, 100 mils of water, that's not changing. That's a variable that stays consistent.
Right, because 1 gram of water is 1 milliliter of water. So,
Okay.
And what we've got here is we've got, in the key, we've got different salts, right?
Yep.
So different graphs will have different salts placed on them. And we've also got the temperature graphed across the x-axis down here.
Okay, and there's no set rules for solubility of solid salts because, boy, those dots, those lines are everywhere.
No, sometimes it can increase as temperature increases, and sometimes it can decrease.
Okay, so there is no blanket statement for solids.
Yeah, I think in the last video we did say that there was a blanket statement for solids that as temperature increases you tend to get warmer. But that's just the general statement.
Yeah, that was
so
if
you want to know the specific rule, you've got to actually look at the solubility curve for the specific salt you're talking about. Here's a question at the top. Which salt can you dissolve more of at 60 degrees Celsius?
I'm just glad it's a bigger graph.
Yeah, it's a nice, much bigger graph. So we don't go over here because over here we've got solubility, right?
Yeah, we have to find the 60.
60 degrees Celsius should be down here.
We're looking for a line that went up.
Which can you dissolve more of at 60? So we're actually just looking for the highest at 60. So this would be the lowest down here, whatever this blue thing is.
Right, so something that went up.
So the thing
from the original.
The thing that's red here, this is the highest one on this chart.
Yep.
So I'd say that it is Na2HASO4.
Ah, you were right.
Okay. All right, we got a new change, new question. This is the question you thought it was asking.
Okay, which salt shows the least change? Okay, so which salt shows the least change in solubility from 0 to 100 degrees Celsius? So you're looking for one that's basically flatlined.
Right, yeah, something that's not changing much at all. So you could do it visually or you could do it mathematically. I think mathematically it's going to be a little bit tougher because you got to take figure out, okay, 5 grams dissolve here at 0 degrees Celsius, 33 grams here at 0 degrees Celsius. So the green line happens to be 33 minus 5, which is 27. Or the better way to do it.
Visually, the pink one.
Yeah, the pink one changes the least, right? It goes from 36 to 40.
It's only 4 grams.
That's only 4 grams. The rest of them are going to all be more than 4 grams.
So that means, hold on, just out of curiosity then, at 100 degrees Celsius, I can dissolve 4 more grams of the sodium chloride?
Correct.
Got it.
So sodium chloride's fairly stable as far as temperature is concerned. The rest of these salts are doing some pretty wacky stuff.
What's that dark blue one? Is that sodium sulfate is all over the place.
Yeah, sodium sulfate increases to a certain point and then starts decreasing.
Huh. We were right.
Okay. What compound shows a decrease in solubility as you heat it up?
Well, we just mentioned the one, the sodium sulfate.
Yeah, sodium sulfate does that, but it doesn't do it consistently.
No,
sometimes it goes up.
Place.
So is there another one that's a better answer?
Yeah, that's cesium sulfate one.
Yeah, that light blue one.
Well, that's interesting. Yeah. Both of them sulfates?
Both of them are sulfates, and both of them tend to decrease. The cesium sulfate nonahydrate.
What is the solubility of sodium chloride at 60 degrees Celsius? Well, that's nice and easy. Sodium chloride is the pink one.
So 60 degrees, we look at it. Here's the pink one.
38.
So it looks like about 38 grams per 100 grams of water, right?
Yep.
So hopefully that's what it says, and that is what it says. 38 grams per 100 grams of water.
These are easy.
It's just a matter of reading graphs here. How much sodium chloride could be dissolved in 100 grams of water at 80 degrees Celsius?
80 degrees Celsius, sodium chloride 80, for the pink.
Work your way up. There it is. Nope, I'm sorry, sodium chloride. I went up to the red, didn't I?
Yeah.
Here's the pink. 39?
About 39, yeah. 39 grams per 100 grams of water.
And about 39 grams per 100 grams of water. That's exactly what it says there.
How much sodium chloride could be dissolved in 200 grams of water? Well, if 39 grams in 100, I would imagine
twice as much,
Yeah,
right?
twice
Because
as
it's twice
much.
as much water. So 39 times 2 gives us 78 grams
in
per
200
200 grams of water.
If a saturated solution of sodium chloride is made up at 80 degrees Celsius and it is cooled to 60 degrees Celsius, what kind of solution exists? Well, if you made a saturated solution at 80 and cooled to 60, isn't that going to be a supersaturated?
Yeah, yeah. As long as you cooled it at a reasonable rate, which it doesn't say that you cooled it quickly, so.
Yeah.
Yeah.
Don't tap it. Don't
So-
throw another crystal in.
Supersaturated.
Supersaturated. That's the definition of a supersaturated.
Now,
right?
if I tap it or I throw another crystal in,
It's no longer supersaturated.
longer
Everything came out.
right.
Well, that was easy.
Yeah, I guess we'll work some more on this in class, huh?
Yep, on to the math of calculating concentration. Bring your calculators.
Okay, see you tomorrow, guys.
Bye.